Welcome to Mancinelli's Math Lab. Thank you for subscribing to my channel. This is not a requested video, although I did want to cover it. It's from the material of exam FM. I haven't covered anything regarding continuous annuities, so let's do that now. These are the details. We're given that basically we have a continuous annuity with payments of 1 every year. So the interest is compounded continuously, right? So this is the notation we use for an annuity, a continuous annuity with payments of 1 every year. This is for 20 years. This is for 10 years, and we're given this equation. We're given that the present value of a continuous annuity where t equals 20 payments of 1 is 1.5 times the present value of a continuous annuity for 10 years. We're interested in the accumulated value after 7 years. So I kind of just made up some notation right there, but whatever, right? We have a interest rate I, which is strictly greater than 0. That's important actually. These little details actually do come up. So I'll show you what I mean by that. Here is what we want to do. I want to deal with this business right here. Now, what is the definition of a continuous annuity? Well, there are a couple of different formulations for this, but in my experience, it has been useful to write v to the t. V to the t would usually go here. It's more useful, I believe, to write it as an exponential. E to the negative 20 times delta over delta is equal to 1.5 times 1 minus e to the negative 10 delta divided by delta. So what I mean here is, remember the relationship between your force of interest delta and I, right? Let me write over here real quick. We know that delta is equal to ln of 1 plus I. And I'll keep that up because I'm going to resort to that actually later on. Wonderful. So, this is just an equation. We can immediately cancel the deltas. That's no problem. And hopefully you're seeing that this looks like a quadratic. There are several examples of this situation for these types of questions. We often get equations that look like quadratics, and here is another situation of that. So let's clean it up a bit. I do like to write the highest sort of power first. In other words, I want to write e to the negative 20 delta first, and I also want it to be positive. Do some algebra, you should get the following. This is e to the negative 20 delta. What's going to be this coefficient in front of this guy? It looks like it's going to be minus 1.5 e to the negative 10 delta. Now what is going to be my constant? Well, I have a 1.5 here, and I need to subtract 1. So it looks like plus 0.5. Quick side note, I always worked in fractions before I started studying for exam FM. There's so many annoying so many annoying decimals in this exam. I just pretty much use decimals for every situation, and so that's what I've done here. Now, hopefully you're seeing this looks like a quadratic. I could use the quadratic formula, or since I'm not rushed for time, I do recognize, and hopefully I'm not, well, maybe I am insulting your intelligence a bit. I'm going to do the x method. Sometimes it's called the magic x method, which I never understood. Nothing magic about it. I'm coming up with the numbers myself. A times c is 0.5, and b is negative 1.5. So I'm looking for two numbers which multiply to be 0.5 and add to be negative 1.5. Well, this is negative 1 and 0.5. Negative 1 times negative 0.5 is 0.5. Add these up, I get negative 1.5. So it factors nicely. Leading coefficient is 1, so I can jump right to the factorization. This says the following. It says that I have e to the negative, actually, e to the negative 10, e to the negative 10 delta minus 1, and e to the negative 10 delta minus 0.5. Wonderful. Now, What is the situation here? We use a zero product rule. Two things multiplied by zero, one or the other must be zero. So therefore, e to the negative 10 delta is equal to 1, or e to the negative 10 delta is equal to 0.5. Now is the situation where I use this piece of information right here. Think about it for a second. I is greater than or equal to 0. Check out this equation here. If you like, log both sides. What does this tell you about delta? Think of it this way. I mean, what power of e gives me 1? Well, delta must be 0. Delta equals 0 here. We don't want that. We don't care about that. And over here, let's isolate delta by taking natural log. Over here, this tells me that delta is equal to the following, ln of 0.5 divided by negative 10. That's what we want. And don't be afraid, this is a positive number. Because remember, ln of a fraction, ln of a number between 0 and 1 is negative, negative over negative is positive. So we're good to go there. We can finally answer our question of finding the accumulated value after 7 years. Let's go ahead and do that. Let me get rid of some of this stuff. The only thing I need is this guy. So let's do that. Now what I'm going to do, since this is kind of a strange question to ask, is I'm going to, conceptually, what I'm going to do is I'm going to find the present value of my continuous annuity after 7 years, and then I'm going to basically future value that 7 years. Let me show you what I mean. So this is what we have. And just think about this intuitively. Draw a time diagram if you want. The accumulated value after 7 years is equal to what? It's equal to 1 plus I accumulate the present value seven periods or 7 years. Accumulate. I hope this makes sense to you intuitively. Take the present value of my continuous annuity. That will give you the value at time 0, but now accumulate it 7 years. Oh, that's the accumulated value after 7 years. Hopefully this makes sense. And we need to keep in mind the relationship. Again, I just erased it, but remember, we do have the following. We do have that delta is equal to ln of 1 plus I, which means e to the delta is equal to 1 plus I, which means e to the 7 delta is equal to 1 plus I to the 7, right? So I'll replace this with my expression involving e as well as the formulation of delta I have here. So that will take care of it, and we'll be good to go. So what does this tell me? So therefore, we have the following. The accumulated value after 7 years is equal to this business, e to the 7 delta, which is this, ln 0.5 divided by negative 10, times the present value after 7 years. Let's get rid of this real quick. Hopefully you wrote that down. Remember that we have this, e to the 7 delta is equal to 1 plus I to the 7. Wonderful, wonderful, wonderful. So now, let's finish this off. This is time, so this is this piece. This is this piece right here. The present value of a continuous annuity after 7 years is the following expression. Using the definition from before, it's 1 minus e to the negative 7 times delta, which is this business, ln 0.5 divided by negative 10, and then divided by delta, which is ln 0.5 divided by negative 10. Punch that into your calculator. I'm going to save you the time. I did it previously, but what you should get here is about, there's some rounding, but there's about 9.01. So that takes care of it. Tell me your thoughts. I hope this was helpful.